What's up, peeps? So this is not in it's not in your notes. So don't worry about trying to find the page. I'm just going to talk about the lab and what you need to do. Okay, so here's what you have. You should have a piece of paper, right? Your tape that has lots of dots on it, and the dots hopefully look something like this. Yeah, there'll be two of them in every place. I'm just going to draw one from here on out. So they'll start, close together, and then as you go along, they'll get a little farther apart and a little farther apart. I'm exaggerating; they'll never get that far apart. But you can see, hopefully, from this that the mass that you drop through that thing accelerates, gets faster because gravity is pulling it with a constant unbalanced force. So here's your job, okay? Your job is to figure out, and I'm going to read some off this lab. Right, we're in activity 2. It says, let's see, if you know, right, sorry, let me back up. These things are sweet. They burn a little dot into a piece of paper at a regular interval that you control. Now, the interval is, well, when we say 60 hertz, that's a unit of frequency, which means how frequently or how often something happens. So that means that a spark happens. There's a spark 60 times per second, or 60 sparks per second, which means that the time interval between each spark is 1/60th of a second. Make sense? If there are 60 sparks in a second, the time interval between each spark is 1/60th of a second. All right, so what you're going to have, what you're going to end up with is a data table that looks something like this. Okay? You need to figure out during each interval, like here's interval 1, here's interval 2, here's interval 3, here's interval 4, and so on and so on. You need to figure out how fast, on average, the object was going. All right, and so all you really need there is to say that, let's say for interval 1, we can measure a delta x. All right, so literally measure this. We'll call this delta x1. Okay, so let's say that's 8.5. Well, let's see. Why don't we do it in centimeters? And let's say it's less than a, oops, that would be too short, wouldn't it? Let's say it was 8.5 millimeters, all right, less than a centimeter. And let's say I'll do down here, here's delta x4. You'll have 2, 3, 4. And let's say that delta x4 was like, 1.65 centimeters. And notice, I'm trying to use a good measurement technique here, which means that if your measurement device, in this case a ruler, only goes down to millimeters, you ought to try to estimate one more significant figure, really. All right, estimate if it's right on the line, we'd call it, if it's on the 8 millimeter line, we'd call it 0.80 centimeters. Here we're saying it's between 1.6 and 1.7, so we call it 1.65. You should be able to tell if a mark is on a line or between them. Okay? And so on and so on. Now, for this one, what we also want to calculate is we're going to calculate V average, in this case in centimeters per second, for each interval. Okay? So again, that's just going to be a calculation, and don't write this in your table, but you can do this, delta x over t. All right, here's our delta x. And again, the t is 1/60th of a second. Okay? So let's see. If something goes 0.85 centimeters, 0.85, I'm going to show you a trick here. 0.85 divided by 1/60th is the same as times 60, right? So just times 60. That's 51 centimeters per second. Right? Down here, 1.65 times 60 is 99 centimeters per second. Again, dividing by 1/60th of a second is the same as multiplying by 60. Fair enough? So you'll do that for, let's do up to, say, 20 intervals, or as many as you have, but 20 is plenty. All right, if you have more than 20, just stop. If you have less than 20, no big deal. Do as many as you have. Okay? Now, one thing you ought to look for also is sometimes you'll see like that there's dot, 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 and it looks like the machine might have just missed a spark. If that happens, I'd say just draw one in where you think it might have gone. Do your best there, okay? These things aren't perfect. Sometimes they miss a spark. Okay, so you got that data table? Excellent. Now, on your graph paper, what I want you to graph or plot is velocity versus time. Okay? So, at each interval, what was the velocity? Now, what I recommend you do here is do it in 60ths of a second. Okay, so at the first 60th, how fast? At the second 60th, how fast? At the third 60th, how fast? At the fourth 60th, how fast? As opposed to doing, this is 0.000167, this is 0.00333 or something like that. Don't bother with that. Just write them in 60th of seconds, 60ths of seconds. Okay? Ideally, you have, a pretty good plan for what this graph should look like. This is a graph of velocity and time. So, ideally it comes out in a way that does not surprise you. Or, maybe better than that, it comes out in a way that you say, oh, okay, I understand what the acceleration due to gravity really, what kind of acceleration that really is. So I think you make that graph, and you come back tomorrow, okay? We'll go from there when you get back tomorrow. I think that'll do it. All right, let me just make sure. So we have a way to figure out the average velocity at every interval, right, by measuring the delta x and then doing our simple equation. Okay, fine, yep, up to 20, and then we're plotting velocity versus time. Okay? Yes? Right? Okay, see you tomorrow.